Hello everyone, I am Venkat Narayan TL, a second year student at Sri Venkateshwara College of Engineering, Bangalore. So I'll be telling about the topic principle of inclusion and exclusion. So let's get started. The principle of inclusion and exclusion is a powerful technique in combinatorics and set theory used to count elements accurately when there are overlaps. It is commonly used in solving problems that involve counting elements belonging to at least one of the several sets like survey data, preferences, etc. The idea is to add the sizes of each individual set, subtract the sizes of pairwise intersection, add back in the size of triple intersection if any, and so on. So cardinality denoted by mode A means the number of elements in the set A. This principle ensures accurate results when counting overlapping data. So basic counting problem, let's take an example, that is 40 students study maths, 30 students study physics, 10 study both, and if we simply add 40 and 30, we mistakenly count the 10 students also who study both twice. So the correct approach is to use the pi formula for two sets, that is A union B equals to A plus B minus A intersection B, that is A value is 40 and B value is 30 minus A intersection B value is 10, which is equals to 60. So this is the correct count of unique students. This simple case illustrates how pi corrects for overcounting, a common error in the real world data. Moving on to pi formula for two sets. So let's consider two sets A and B. The pi formula is A union B equals to mode of A plus mode of B minus mode of A intersection B, which means you're going to add the total number in the each group, subtract the overlap, that is those which are common in the each group, and then we are going to subtract them because they were counted twice. And the applications are people who subscribe to two streaming services, employee with overlapping skill sets, customers using multiple platforms. So these are the most common examples for a particular two sets problem, and this one of the most practical tools for data analytics and statisticians. Similarly, for three sets, pi formula is the formula extends naturally to three sets, that is A union B union C, that is equals to mode of A plus mode of B plus mode of C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C, which is known as alternating sum. First, add the individual sets, then subtract pairwise intersections, finally add the triple intersection. So we use these in marketing, that is customers who like three products, that is A, B and C, and students enrolled in three courses. Okay, students enrolled in three courses, tracking bugs occurring in multiple software modules. General formula. So the general inclusion and exclusion formula applies to n number of sets and continues the alternating sum pattern. So the formula is mode of UAI equals to sigma AI minus sigma AI intersection AJ plus sigma AI intersection AJ intersection AK minus so on, plus minus 1 to the power n, and then mode of A1 intersection A2 intersection A3 and so on till AN. And this is particularly useful when you are doing for more than 3 sets. So there are more than 3 sets overlapping categories, okay, 3 overlapping categories, and you are working with a large set of data in business analytics or database system. So pi allows us to extend logical thinking into complex domain without getting lost in the overlaps and miscounts. Application example. So here is a classic application of pi. That is, in a class we take 25 who like tea and 20 students who like coffee and 15 who like milk. Okay, so who likes tea and coffee is 10 members, and then who likes tea and milk is 5, and coffee and milk is 3. So 3 likes all the 3, that is coffee, milk and tea. So we apply the pi formula, that is A union B union C, for that is we used for 3 sets, and then this is the thing. So A union B union C, that is equals to A plus B plus C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. So this formula here, A is 25, B is 20, C is 15, and A intersection B is 10, and A intersection C is 5, and B intersection C is 8. The plus all the 3 is 3, that is equals to 40. So this tells us 40 students like at least one beverage, and this technique is widely used in Venn diagram problems, competition maths, and professional data analysis. Okay, so some of the real world applications are the principle of inclusion and exclusion is not just a theory thing, it has a numerous real life applications also. So, they are used in computer science for optimizing database query that involves overlapping filters, and network theory, finding reachable nodes in overlapping subnetworks, probability, calculating chances of at least one of the several events happening, and software testing, finding bugs to multiple modules, and market research, estimating customer segments with shared preferences. So pi is also a foundation for solving Olympiad, GATE, and other competitive exams, making it must know the concept. So I would like to conclude the video by saying that we have learned important concept that is called pi, that is principle of inclusion and exclusion. I hope you all have understood the video. Thank you.